what we are going to do, this is the one that I think kids will struggle with a lot because it's so dependent off of one before. And you're going to know the one I'm talking about when I say the name. Look. These are the ones I love the most because it's like, do you really know your stuff?
No.
No.
I can already tell you that.
Oxyacid nomenclature.
Thank you.
Oxyacid nomenclature. Oh yeah.
So anyways, back to my story.
So whenever we looked at this, we looked at oxyacids. That's what this first column is going to be, is the polyatomic suffixes. So those oxyanion nomenclature is what we're going to fill in here. So it's just like with before, every one of them have a root. The root is still there. It doesn't leave. But then the differences was in the ending. I can't remember what colors I chose, so they're probably
Blue. It was blue.
So if we remember, the first two had the endings of 8. And the last two had the endings of I.
I don't have much colors for this one.
Oh god, it's definitely broken now.
But then we had a change up whenever we looked here at the top. The first one, that was the one more oxygen than the root, had the prefix of per. It was perudate. If you remember back to the example we did perchlorate as that example. Then we have rootate. That's the root. That's the one we memorized. That's still the trick here. Memorize the root. You're going to see why in a moment. Rootate. One less oxygen. Then we had hyporudite. Hyporudite is 2 fewer oxygens.
If there's a hypo, is there a hyper?
No.
It would be cool though. So anyways, whenever I showered, I got
So, when we look at the oxyacid suffix, there's a subtle change. Here's the change. It's this simple.
spill the beans.
To go to the oxyacid, 8 goes into ic acid. Ite goes to us acid. O-U-S.
What?
I see.
What are ick eyes at? What are those
These
things?
are the suffixes at the end. So everything stays the same. So we still have the roots.
I thought it was a ghost.
And we still have the prefixes on the ones that have the prefixes. But now the difference is in this ending. So if it ended in 8, it now ends in ic acid. If it ended in ite, it now ends in us acid.
I don't like this one.
Yeah, this one's kind of funny.
Rudous acid. Oh, no, it's funny. I like that one, didn't I?
That was a little funny.
So whenever I got out of the shower, I put my pants on, I went to go lay down with my blanket on, and I was like, man, it's too hot.
So we got to get some examples in here. So some examples we can look at. Or y'all still writing that?
I'm done, I'm
You're closer,
ready.
Tammy.
I'm balling, let's
I'm
go.
almost done.
Choo choo!
Us acid.
All right. So if we looked at it, and I'm just going to do
Chloric
So sure.
acid.
looks familiar with you. Hypochlorous acid.
I don't think I'm familiar with that. What do you mean familiar?
What is it based off of? I'm going to show you how to work these.
Do we have to
Okay?
write, do we have to write acid after all of those? like-
Yes, if you don't put acid, you're wrong.
Oh, okay.
It's not one word.
It's an acid.
What makes it an
I'm
acid?
kinda hungry.
I'm going to give you the formulas for them. Then I'm going to show you the trick, because where we had the Wi-Fi debacle this morning, you're probably going to run out here a little confused.
Okay, so
So when you look at it,
Hydrogen ion. I don't know.
perchloric acid. Ic acid came from 8, so I do the reverse. I put 8 perchlorate. What was perchlorate? ClO4 minus. Here's the thing with acids. They give off hydrogen. So if we go to an acid, all we have to do is add hydrogen to the front, and the charge tells us how many hydrogens to add.
you may have believed him, but did you trust him?
So I add hydrogen, it's a -1. Now the negative goes away
Okay, never
But
mind.
I won't.
because the hydrogen balances out the charge.
Sorry.
Just don't shave my head.
Listen, tomorrow I'll focus on this a little bit more. We're just scratching the surface today.
Tomorrow.
Okay.
Oh, yeah.
I thought that they were.
Okay,
Oh, this makes sense.
so I got up.
So then, chloric acid is HClO3.
He's fuming.
And it was
Chlorous acid,
It was really, really hot.
HClO2. And then whenever we look at hypochlorous acid, Tanner's going to tell us what it is.
Well, HClO. But it was really, really hot.
That's correct. It's HClO. So HClO is for hypochlorous acid.
Yeah.
This is the trick that everything comes down to, is when you look at acids, what acids are. Now, there's multiple different definitions of what acids are out there. I try to make everything simplistic where you can understand it. That's my goal. So when we look at acids in chemistry, acids are molecules that give off hydrogen in solution. So why am I telling you this? This is the reason why, because I'll go ahead and tell you, this is the 5th naming rule you've got from me. Tomorrow you're going to get the 6th. Guess what the 6th one is?
What time is it? Basic.
It's another acid.
Wow. What is
You've already done it without knowing it.
What?
What?
What was it?
Potassium hydroxide, calcium hydroxide.
Uh,
Because what bases do is they give off hydroxide ions in solution. They don't have weird naming rules like acids do. The reason I tell you this,
What?
He's a terrible
if
actor.
it is an acid, and hydrogen
What?
must be first. That's why you see here, hydrogen, 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 hydrogen. I instantly look at those and I know acid.
I was.
Anytime you see hydrogen, you know one thing for sure. You are dealing with an acid.
Yes.
Besides that, have a great, wonderful rest of your day. Love you all. Mason.
And I played shipment only for like 5 hours straight, and it deteriorated my brain. All I heard that night were gunshots because of how I had like Every game I had like 40 kills and 30 deaths every single time. It was ridiculous.
I played Rebirth, not Rebirth, Insurgents in Warzone last night, which is like Warzone except you respawn on a small island. And I would, I would spawn in, I would go, clunk, clunk, clunk with that fat revolver. I would knock one dude and then I would just die again.
I had the worst build of all time. I was using what I like to call Big Bertha, which was a, not the automatic, but the shotgun with the magazine. And I gave it the shortest barrel and shortest stock possible.
Alright. So, today we gotta get the last of the nomenclature rules in, which means we will be balling out. Come next week, we'll have practice, get the practice rolling, and then next Friday.
What was next Friday?
Quiz.
No?
Next Friday will be the quiz. Now, I want to tell you this, heads up to you on this, okay? Because I know in typical cases, I tell you, once you learn it all, it's fair game. There's so much and it's such a weight that the quiz next Friday is just nomenclature, okay? That's all it is. It's either you have the name, you give me the chemical formula, or I give you the chemical formula and you give me the name. Okay? That's it. That's all it is. So please, whenever you're studying, study these nomenclatures. Practice sheets. You got those first two. I got another two I'll give you. Alright? And I'll send you the answer keys. Study. And use the whole week to study. Do not wait till last minute. Okay?
Favorite type.
I'm telling you, this is hard. This is difficult. It is. But you can do this. Alright? So, we hit oxyacid nomenclature yesterday. I gave you a very brief introduction into acids, but I want to re-hit that again. So, whenever we look at acids, we know it's an acid because it always starts with hydrogen. It's a dead giveaway whenever hydrogen is first, and there's a reason for this. And I'm going to give you a big fancy term today, and you all are going to be like, what the world? But I'm going to explain the term to you to where it makes some sense. So the reason this is like this is acids, they always give off hydrogen in solutions. When you look at this process of whenever they're doing this, they're giving off hydrogens in solutions. This is called protonation. I probably misspelled that. If I did, I apologize, but it's protonation. The key to protonation is when you look at this, is why do we call it protonation and what is protonation? The key is the first little base word there, proton. The reason for this is what's happening. When you look and we call this protonation, it looks confusing at first because we're giving hydrogen off, but really analyze what's happening. So whenever we have an acid, we have hydrogen bonded to it. Look at hydrogen. Bohr's model of hydrogen. Hydrogen has how many protons?
One.
Has one. How many electrons?
Oh, one.
One. Both of them are one. But then what happens in the acid is it's so strong, what it does is takes the electron away. So when it does this, it forms a hydrogen ion, but what's really left? Just a
Proton.
Just a proton. That's why it's called protonation. Got it? This is what we're looking at of what's taking place. Am I super concerned that you have an understanding of that right now? No. When I'm really going to be concerned is next year when you're an AP camp. Because like a good 18% of your AP exam is like understanding of acids and bases. You'll have a blast with me because next year we will focus heavily on intermolecular forces, which is 18 to 22% of the test, and then acids and bases, which is another 18% of the test.
Why did you say the electron goes away?
Because the other part of the acid pulls it.
Oh, okay.
So like, I'm getting ready to explain to you binary acids, so a really good example of these are binary acids. But when you look at it, a lot of the binary acids we have are the strong acids. There's 7 strong acids. So a good one is like what's inside your stomach. So inside your stomach, if you're familiar with it, if you ask somebody, you probably could name it and tell me it's hydrochloric acid. You're going to see why it's hydrochloric acid today. But here's the thing, look at chlorine. Chlorine has a really high electronegativity, so it has a really strong pull on hydrogen's electron. So it's really good at pulling those electrons away and giving off hydrogen and ions in the solution. This is why like acids are really, really bad, by the way, is they love to rip electrons, man. They just,
So that's why they eat away at skin and stuff, right?
yeah, part of it. It is, I mean, it's not friendly. That's like another one you need to worry about is if something is an oxidizer, which we'll get into that in this class, but we talk about oxidizers, you have to be concerned about them because what that means is they're really good at stealing electrons. They love to take electrons. So if something's an oxidizer, like you'll see me, and honestly, I'm really relaxed in the lab. I know when something's serious and when I need to take precaution. You see me putting on gloves, I'm dealing with something that can hurt me, just being honest. So it happens. Like one year I done a demonstration that I'll do for you guys this year. But whenever I did it, I set the container after it that had 30% hydrogen peroxide in it, which is a really strong oxidizer. I set it in the sink and I turned the water on it and let water just run in the beaker and let it go down the sink so that it would just dilute out. After about a minute of water running straight into the beaker, I grabbed the beaker, turned it over, and thought I'd be okay. I turned it over so it went all over my hand. I just flipped it back. I rinsed my hand off. And that's how fast it was. So that's how fast I was exposed. That's how fast I diluted it. About 10 minutes into the class of me teaching, my hand is in agony. And it keeps hurting. And I'm sitting there, I'm rubbing. I'm like, what in the world is going on? So finally I look at it. And from here over on my hand, on both sides, the hydrogen peroxide oxidized my hand to the point it had turned it white, and I could literally see my pores. There were holes all through my skin. So at which point I went and I washed my hands, and I'm like, holy smokes. So
Is it like a stinging burn? Or like what is it?
it was stinging.
I feel like
She's been
I
saying,
feel like I don't know.
she's been saying that she wants to touch
I
a
want to.
really strong acid.
It's not a really strong.
You do not want to touch
But
her.
it's just to see what it's like. I totally think that one saw drop where she has to stick her hand in acid to get the key out. I think I could do that. I feel very confident I could do that.
I'm concerned about getting out.
If they put me in a saw trap, I'm done.
But here's the thing is, okay, if you, like strong acids hurt really bad. Okay, worse than that are strong bases though, because bases can actually get underneath the skin and then react, and well, you got a layer of skin over top of it, so you can't get to it. You gotta be careful with it. That's why like coming up, we'll do some labs and I'll be like, you are to wash your hands. There's one lab coming up that we'll do that we deal with such a strong acid, you are not allowed to touch it. I actually have to be the one to pour it. Like it's stronger than what's inside your stomach. Yeah. It would light you up. Anyway, enough of talking about acids. If I haven't introduced you in AP chemistry yet. Hey, yeah, when you know, all right, so we hit oxyacid nomenclature yesterday, but now I want to hit what's called binary acids. Okay, binary acids go by a totally different set of rules. Oxyacid's based off of oxyanion nomenclature, so you've got to get those two together. And trust me, we're going to do practice, okay? But binary acids are simple. Here's the thing. Just follow the rules, and I will point out to you the hard part the kids miss. Here's the thing. Binary acids are made of two elements. Yeah. It's composed of two. Hopefully you can tell me what the first one is.
Hydrogen.
How did you know?
I guess.
First element,
All of them have
hydrogen.
all acids.
All acids have hydrogen first.
Good job, Judy.
Besides the drug of acid, that's no
You
count.
good?
Huh?
Those clips of Siege have melted his brain.
So,
Thinking about it.
Yeah.
Just thinking about it, throwing them out.
I don't want
so the first one you have is hydrogen. The second one, now this isn't a typical case. It doesn't always apply, but in this class, this is how we're going to look at this. It's normally one of the halogens. If you don't know what I mean by halogens, this is column 17 on the periodic table. Bless you.
Thank you.
Welcome.
And Mr. All.
Yeah.
All right, me, you, Dale, Eli, we all playing Siege tonight or what?
Yeah.
Boys, y'all
Are
would
you
call me
streaming? I want to
playing
watch.
No. It'll be funny. Eli's probably just as bad as you are. I've heard you suck at Siege.
Just invite me to the party.
Yeah.
Like y'all would not want me to be a part of the team.
Well, I mean, you can't play
Can
ranks
you
yet,
guys stream it
so.
so I can
I
watch
explain
it?
to you like this: if you were picking teams to play Siege, I've never played it in my life. I'm gonna be the last pick.
No.
Well,
You know, like the little scrawny kid that's like.
I would
barely,
pick you over Hunter.
You know,
No,
3 foot
I'm
high.
I'm not lying. On everything I love, I would pick you over Hunter, okay? He's the worst player I've ever seen.
I was the guy that, for like a bachelor party, we took a guy to a field and took him paintballing. And I was the guy that, like, when we was playing a game, I just kept trying to charge and just run at the building to get in, and literally got to the point that the guy was just sitting there at the window, posted up, and he said, like, he did it multiple times. He let, here comes Kevin in 3, 2, 1.
Well, you don't worry about that. There's shields in the game. You could be Blitz or Monty
Or Oryx. You can just run at people.
or Oryx.
Is this how y'all feel whenever I'm talking to you about chemistry?
Yeah.
Yeah.
This is how it is whenever I'm talking to Mary about stuff. Because she'll look at me, and it's just like, it's, you know, like the TikTok has got the dog sitting there. Dun, dun, dun.
He would be a good Ying, but I'm a Ying.
All right, so here's how we name it, okay? So here's the name.
Then we need to play R6 again one day.
I agree.
My KD would not.
All right, so the naming, first part. This is the piece that kids miss, okay? I know you're probably scared to death. You have oxyacids and you have binary acids. How do you tell the difference? I'm going to show you. First part, the name starts with hydro.
Oh. Oxyacid, that's oxygen.
Woo!
Did you know that, Eli?
Oxyacids names do not start with hydro.
What? Oh, yeah.
Second part,
No.
remove the ending
How do you guess that, Danny?
I don't know, I'm really smart.
of the halogen. Add ic acid.
So hydrochloric acid, is it binary acid?
Yes. Which, we use this as an example. I can look at this and I can see I have two elements present. Hydrogen is first, which tells me I have an acid. There's two elements, which means it is a binary acid. So I'm going to start with hydro. Cl, that's chlorine. We keep the root, chlor. Then I add ic acid. To the person that asked yesterday, it's the same thing here. Yes, you have to put acid or it's wrong.
Hydrobromaic acid.
Hydrobromic.
Hydrosulfuric acid.
That's
Hydro-
powerful.
Hydrosulfur.
I will be honest with you, I never realized this until I started teaching other science classes, but there is a different terminology and way of speaking in different sciences. Like, you know, God bless Mr. Short, all his anatomy junk he knows. Okay. All right, so here we go. Let's look at a couple, okay?
Do it.
Hey, Mr. Hall,
Do it.
how do you make an acid out of the 53rd element?
A binary acid to be
Binary acid to
exact.
be exact.
You want to know the name?
Oh, man.
Okay.
All right.
All right.
All right.
We have some ideas, guys.
The joke went over my head. I immediately threw.
Remove the ending of
Oh, oh, okay. I didn't know which way it was. I had to think about.
Hang on a second, I need to check and make sure that something is on something. Okay, we're good. Okay, so I gave you 4 examples up here. I'm gonna go ahead and tell you, they're not all binary. Okay, I did this to you on purpose.
Wow.
I'll work through it with you, okay? So you get them wrote down. We're going one by one. I especially did this on the bottom to you on purpose because I want you to catch something. I have to get you to the point that you can catch and see things so that I don't trick you up. Literally in all the practice, I'm going to go ahead and tell you, every day you come in here next week, there's going to be practice. And the reason for that, I'm trying to trick you into practice so that Friday I don't trick you. It's all a confidence booster. So I have hydrogen first. Hydrogen first tells me acid. But now there's 2 types of acids. So I look. How many elements do I have present? So what type of acid? Oxyacid. Since it's an oxyacid, it's based off of oxyanion, so it's based off of polyatomic ion. So if I look here, the CO2, I can work backwards. There's 2 hydrogens, which tells me this was CO2, 2 minus. What is that polyatomic ion?
Carbonate.
Carbonite. One less oxygen, carbonate. So, use the rules. Ite goes to us acid. So carbonous acid. That's it.
I like that.
That's a weird. I don't like that one. I hate that one.
Carbonous? That
Carbonous.
sounds cool. That
That
sounds like
sounds
carnivorous.
repulsive.
Carbonous? I know. It's
Next.
awesome.
Oh.
I have hydrogen first, tells me acid.
Yes.
Why are you smiling?
There's two elements, so it's a binary acid. What do binary acids start with?
Hydro.
Hydro. Got iodine, so we keep the root.
Mason would love this.
Hydro.
Remove the ending, add ic acid.
Hydro. Iod.
Hydroiodic
Yeah, that's what I was gonna say.
acid.
I really thought y'all stumped him.
No, I just thought it funny.
Only if Mason was here.
What? If Mason was here, he'd have no idea what's going on.
That's true.
Bromic acid and hydrobromic acid. I gave this to you on purpose. Is there a prefix hydro here? No, but there's acid, so it means oxyacid.
So,
Work backwards. Ic acid came from 8. So look, make, and write down bromate. If you remember, bromate's BrO3 minus. Now we have to make it an acid, so add hydrogen to the front. The charge tells you the number of hydrogens. I need 1 and erase the charge. So that's bromic acid,
Why would I erase the charge again?
because the hydrogen takes the charge away.
Michelle, something tells me I should study this polyatomic ions before this quiz.
You think? Hydrobromic acid. Dead giveaway here. I give you the name, hydro, binary acid. Brome comes from bromine. So it's Br.
Is this HBr?
The charge of the Br would be -1 because it's in the 17th column. I need hydrogen to make it an acid, and I only need 1 because the charge is
Hooray!
-1.
Will we ever have to like? Will it ever not be neutral because binary acids bond with 17th column?
In this class, on a quiz question of strictly nomenclature purpose, it'll always be neutral. Now, later on in the class, I can give you an acid, like there are acids that will protonate multiple times.
Yeah.
So I can give you an acid that actually has a charge. So like, one popular one is this. But then the first hydrogen will actually protonate off and give you this. I could give you that in a problem, but I'm not gonna ask you to name that. Okay? I ain't worried about that. Does that answer your question?
Yes.
I just don't want to catch you off guard. Hey, have a great, wonderful weekend, everybody. All right, here we go. Hey, so I'll go left to right and come back if y'all want to, or go top to bottom, left to
Top
right.
to bottom.
No, left or right?
No, top to bottom.
You read left or right, not
No, you
top or
don't.
bottom.
I read top to bottom.
Okay, I'm gonna go left to right. All right, so HF, first thing, hydrogen's first means acid. So I know I'm dealing with an acid here, so I'll look at what type of acid. It's 2 elements, so it's a binary acid, so I know it has to start with hydro, because only the binary acids start with hydro. F is for fluorine, so we keep the root, fluor, then I add ic acid, and that's the answer, hydrofluoric acid. Next one
Yeah.
is nitrogen heptasulfide. Dead giveaway, I see hepta, which means it is a molecule that uses prefixes, so it's spelled out for me. First one is nitrogen. There's no prefix, which tells me there's only 1. Next is sulfide, comes from sulfur. Hepta is 7.
Uh-huh.
Oh, wait, I had it right. I totally.
Boron.
Now here comes a fun one. Threw this one out there to see. Man, this thing's like, okay. BF3. If you look at boron, It's in the P block. It's to the right of the staircase. Non-metal bonded with fluorine, which is a non-metal. Two non-metals make it covalent. There's no overall charge, which means this we name based off of prefixes. So there's only one first, so I don't use mono. So boron trifluoride. Boom. Next one, oxalate is your good handy friend off of polyatomic ion. And what is oxalate?
C2O4, 2 minus.
I was wondering if I was going to get a charge there. C2O4 2 minus. That's just from pure memorization. Next one I gave you will change later on in your life based off of your nomenclature rules when you get into organic chemistry. But as of right now, carbon and hydrogen are what? A covalent bond. So this is hex carbon. Heb.
Oh, sorry, Dexa. I'm still stuck now.
You're okay. Decahydride.
Is that a carbon chain, Mr. Ross?
This is a carbon chain. That's actually, it depends. The way it's written right now,
Depends.
it's just going to be hexane. But that's organic chemistry. Alright, then I have FeCO. So if I look at this, I have iron, carbon, and oxygen. Dead giveaway. There's 3 present, which means polyatomic ion. Find the polyatomic ion. I look for the polyatomic ion. Here we are. Carbon and oxygen. So in this case, I have iron, which is a transition metal, which means I need to name it based off the stock system.
Report to 1035.
So iron, there's got to be some charge for it. Then I have carbon and oxygen. So the normal base is carbonate, which is CO3 2 minus. That's the root ion. This is 2 fewer oxygens than that, which means I have hypo. Carbonite.
Yeah, I didn't get
Anytime we
that.
see CO, do we assume it's carbonate? Because oxalate is also a variation of CO.
Oxalate C2O4.
Okay.
So if you see the C2, then give away you're looking for that. Then you got to look at the charge. There's 1-to-1 here, so that means it's the same as the hypocarbonite, but the opposite sign. So it's iron 2 hypocarbonite.
I did not like that one.
That's nice, wasn't it?
No.
Perbromate. Perbromate comes from bromate, which is BrO3 minus. That's bromate. Perbromate means I add an oxygen, so BrO4 minus.
Yay!
Next one's a little tricky.
Yeah.
This one is, if you follow my rules that I give you, you're not going to get the technical name right, but I don't care. If you follow the rules, I'll still give you credit. Follow the rules. So if you look at it, hydrogen's in front, so I know I have acid. This actually is the strongest of the 7 strong acids, by the way. So this is an acid. I have 3 element presence, which tells me oxyacid. Trick with oxyacid. You have to find the polyatomic present, then work the name off that. So there's the polyatomic, SO4. That will be SO4. I have 2 oxygens, which means that's a 2 negative. So this would be, from our memorization, sulfate.
I like that one. That was kind of cool.
Now that we know that we have sulfate, what we have to do from this point is name it based off of that. We will remove the A ending and it will become ic acid. So if you got this, sulfic acid, I'm fine with that. I will accept that. I will let you know so that you don't go to college and look like an idiot. The actual technical name is sulfuric acid.
Who cares?
So, I'm not worried if you get sulfuric acid, if you give me sulfuric acid, I'm fine with that. You're following the rules and that's what I want. Next one, nitrogen. Nitrogen is a diatomic, so N2. Next one, I threw a little tricky at you, tricky.
Calcium.
So, you look at this one, have calcium first, but there's 3 elements present, which means polyatomic ion. Find the polyatomic ion. There's a polyatomic ion. What is the polyatomic ion's name?
Chromate.
Chromate.
I hated chromate.
Alright, so from here it's calcium. Calcium has a fixed charge, so I don't have to worry about stock system. It's just calcium chromate.
Oh yeah.
NO3,
Nitrogen trioxide.
nitrogen trioxide. This is not nitrate. There is no charge.
Yeah.
I paid a pen.
Barium. Trick. Barium. Are you talking the element?
Or
Ba? Or are we talking the cation? Ba2 plus.
Oh no, I was so close.
Next one. Massive trick
Not the
here.
two.
Ammonium cyanide.
Ammonium cyanide.
What?
I like both of those.
Nerd.
There are 2 polyatomic ions here.
So
I think I just really misspelled that. I did. I switched to it around. So ammonium cyanide is there.
I don't trust that.
There's 4 elements. If there's 4, dead giveaway. There's 2 polyatomic ions. Hydrobromic acid, key here, hydro, which means binary. Since it's a binary acid, I have to start with hydrogen. Then look next. Brome comes from bromine, which is Br. So HBr.
Where did the charge go on ammonium cyanide?
They're balanced. Both. This is a +1. That's a -1.
Oh.
Next, PO2 3 minus. PO2 3 minus. If we were looking at PO4 3 minus, this would be phosphate. But it's PO2, which means 2 fewer, so we add hypo, and it's phosphite. Questions? It's like they fixed the bells.
Oh.
Questions here?
Yeah, I got
Unnecessary.
the field number good.
How'd you guys do?
I got all of them except the iron hypocarbonate because the CO.
It's okay. Hey,
I got about a.
listen to me. Something I need you to do. You guys are really, really quiet when you're doing this practice. The best thing you're going to do now is work together.